Here. The reason I spend time showing you guys how we build those formulas is because in real life, if you need to find surface areas of things in real life, very rarely do they follow the formula. Why would that be? Y is finding the surface area of that cereal box. Why does it follow the formula?
Because each variable will have a set length.
Each variable has a distance in a cereal box, doesn't it? In real life, parts of that prism may not be available. Do you understand what I'm saying? If this was an apartment building, would you count the bottom rectangle as part of the surface area?
Yes.
Why? Why wouldn't you?
Because it's not. Well, I just wouldn't.
Because it's the amount of floor space you have to walk and move around on. What do you count ceiling as surface area in your
It's 2 o'clock in the morning. I had planning before I was sleeping.
So the point I'm trying to make is if I change this drawing to an apartment building, obviously we are not going to have 2 on the bottom because I'm not going to dig the apartment building up, jack it up, and measure underneath if I were, for example, painting the apartment building or coating it with some chemical to keep moss from growing on it or something like that. Do you understand? The formulas work on shapes in math class, so you got to know how to use them. But in reality, they often don't conform to what you have to actually do. So the reason I show you how we build all the formulas is so you can say to yourself, self, I don't need to worry about the floor of this house or something like that. If we were painting the inside of this room, would you count the floor?
No.
I don't see any paint on the floor. Would you count the ceiling?
It depends if you want paint.
Depends.
It would depend. Some ceilings are painted. Indeed. Most ceilings are painted a different color than the walls. So if you were doing the surface area to paint the inside of your room, you would need to do the surface area of the walls and the surface area of the ceiling as 2 different calculations, wouldn't you? Because you might need white for the ceiling and dusty rose for the walls. Or some other crap fake paint store color like that. Everybody understand? That's why you learn the formulas, but that's also why you learn how the formulas get built. Cool? Cool. Turn the page over. I want you guys to do something on this section that is a little bit weird. I want you, first of all, to draw a box down in the bottom corner of this section like that. We're going to come back and do something there. Okay? And then we're going to do 2 things with this question. All right? The first thing we're going to do is answer the question as it is. So we're going to answer this question as it is, and then we're going to answer it in another way. But actually, I'm going to reverse my planning. I'm going to do the other way first. Over here, I want you to change it to a square pyramid with a slant height of 65 and base of 32 feet and feet. Yes, it is. So we're going to start with a square pyramid. If it is a square pyramid, we've already done our definition. Pyramids start from a shape that you know. Repeat that shape, shrinking. Yes? So what is the beginning of our pyramid here? It's a square. So I know if I was going to draw it, I'd have to draw a square on the bottom. And I know that square is 32 by 32, yes? And that's going to rise up to a point. Everyone agrees? Okay. Knowing what you know from yesterday, if I want the surface area of that, you know that that is some regular shapes that have been put together to make a pyramid, yes? What are those shapes?
4 triangles.
There are 4 triangles plus 1 square. Does everyone agree? Okay. So if I were going to build the surface area of this thing, if I were going to build a formula, I would need 4 triangles. What is the formula for the area of a triangle? Who remembers? Base times height divided by 2. Now, 1 second. 8, 9. How would you tell me the area of that triangle? What's the base? What would the base be? 9. What would the height be? So you do 9 times 8, which is 72, divided by 2, and it would be 36, yes? Okay, great.
Oh, I see how that works, because if you were to do it as the area of a rectangle, then it would be like...
Yeah, it's half a rectangle. The problem with high school kids that memorize formulas, if I turn that triangle this way, some of you will tell me that you do not know the base. Or worse, you will say, well, that's a 90-degree triangle, so I'm going to use Pythagoras here. And I'm going to get Pythagoras, and then I don't know the height, Mr. Myers. I'll get the base, but I don't know the height. Everybody see the problem with that kind of thinking? That triangle is exactly the same as that triangle. I just turned it. Is everybody with me? Now, sadly, if I didn't have that there, now you're in trouble, aren't you? Mm-hmm. But the turning of the triangle is bothersome to us teachers. It's kind of like changing the letters. Instead of using X when we're teaching you algebra, we change it to Q. And kids are like, I can't do algebra. I don't know what Q is. But you didn't know what X was. Yeah, X is X. Okay? Okay. My brain's plenty rattled. So, again, base times height divided by 2. Now, we talked about this yesterday. Base is a real problematic word in geometry, isn't it? Yep. Because it can mean the bottom. It can mean the shape you start from. It can mean, on that extra page I made, that can be my base, can't it? Right? So you got to keep that in that's a problem. 4 base times heights. And how do I do a square? It's LW, because a square is just a rectangle, isn't it? Okay. What happens to that 4 and that 2? If I were to do this multiplying, I would have 4BH over 2 plus LW. What happens to that 4 and that 2? They divide, don't they? So I would end up with 2BH, correct? Everybody with me? Mm-hmm. Maybe it'll show up. I don't know. Hey! Plus LW. Is everybody cool to there? Now here's where it gets weird. What height am I referring to there? I'm referring to the height of the triangle, but it's the slant height of the pyramid, isn't it? So if I leave an H there, it's confusing, yes? So this morphs and becomes 2BS for slant height. I know, everybody makes that joke there. Plus. Now, since this is a square, do I need to do LW? It's a square. Aren't L and W the same? So I don't need L and W, do I? And I've already named this guy as the base right here, haven't I? So what should I call it here? Base. And what am I doing with it? Squaring it. That's how we build the formula if the pyramid is square-based. Everybody understand? So, of course, all you would do is fill in the answers. 2 times 32 times 65 plus 32 squared. And we would just do that math with our calculators, obviously. Is everybody cool with the square ones? Square ones are easy. There's a formula for it. Unfortunately, there could also be a rectangle. What's the difference in this? If it's a rectangle, I have this on the bottom, don't I? How long is this side? 48. How long is this side? 32. And I make a pyramid. Does everyone agree? Is it still made of 4 triangles? Are they the same? In the square one, they're all the same. So this was allowed, correct? Is that allowed over here? I have 2 different triangles. I got the green triangle. I got 2 greenies plus 2 blue guys plus 1 rectangle, yes? Well, the green guy is still 2BH over 2. What happens to the 2's? They divide each other out, so they cancel, right? So I get the green BH plus what? What's going to happen to the blue one? I'm going to get the blue BH, and then I'm going to add the LW for the rectangle. Everyone agree? Everyone agree? Now, read this question. I was given a height of 65. Where in a pyramid is height measured from? From the top, where? From the bottom to the top. Up the side or through the middle? Through the middle. Does that height give me anything to do with the slant? No. It gives me this. There is the 65. Does everyone understand that? Everyone agree? 65 doesn't help me find the outside, does it? I need to do some more math. I need this slant height, don't I? What shape did I just make? Triangle. What kind of triangle? A right triangle. Do we have a tool to find the third side of a right triangle? What is it? A squared, B squared, C squared. If you need a slant height or a height, you must use Pythagoras. So I need a slant height, don't I? But this is a weird question, right? Because those triangles aren't the same, are they? So how many slant heights do I need? 2. I need the slant height on the little triangle, and I need the slant height on the big triangle, don't I? So how will I use Pythagoras to find the red slant height? Well, I know Pythagoras A squared, B squared, C squared, right? Except I'm not looking for C squared. I'm looking for the slant height, yes? So I'm going to go ahead and name him slant squared, the red one. It's going to be A squared and B squared from the red side, yes? Well, we know B is 65 squared. What's A? Half of which one? The way I've drawn it right now.
You've drawn it half of 48.
So it's 24 squared, yes?
Yeah.
And then what must I do at the end?
You must make C squared. So just
I got a square root at the end is what I'm trying to get to, right? You're going to do all this with your calculator.
65 and 24.
It's going to be 65 squared plus 24 squared square root. Yes? I can't do that in my head, so I'm just going to write it out. Everybody cool? That's the red slant height. What is the blue slant height? Is this still 65? What's this? What is it? 16 squared. So the blue slant height is 65, the square root of 65 squared plus 16 squared. Yes? Now, where up here, remember, I'm going to erase this, all this. Remember, this was the green one, and this was the blue one, right? Where does the red slant height go? Is that green or blue? That's green because it's the 24. Is it? 24 and up. It's the green one. This is the 24 and up. So didn't it make that? So it's which one? The blue one. And this one is the green one. Is it difficult? No. It's all math you already know. Triangle areas, Pythagoras, there is nothing new here. Is it complicated?
Yeah.
Does everybody understand the difference? Difficult is one thing. Complicated is something else. There is no difficult here. You've been doing Pythagoras since what, grade 7? And you've been doing area of triangles since what, grade 5? Areas when you started grade 5 about length times width, maybe. For some of you from other countries, it was kindergarten. But putting it all together requires what? A lot of thinking and working, right? That's where the difficulty lies. But now the problem where I'm going with here, if it's square, there's a formula. If it's rectangle, not so much. Everybody understand? Everybody with me? Now, if we were going to work all that out, we would go to our calculators and we'd work it all out. Everybody cool? Let's do so. What is the red one? What is the square root of 65 squared plus 24 squared? You're going to get a decimal, so you're going to have to round it off. How many decimal places do I like?
10.
Hundreds. So what's that going to be? This is when I see who remembers how to use their calculators. What is it, Jivan? 69.3. What is the blue one? Well, I get the phone. Go for Myers. I do. I can. Okay. Ria, you are needed in the office to get a message. What's the blue one? The blue one is 2? That can't be. 66.994. So this one was 69.28. Now, what do I do with those two numbers? I come back up to the top. The base on the green one is what? What's the green base? 48. And the green slant height is 66.94. Plus, what is the blue base? 32. And what's the blue slant height? 0.28 plus length times width of the rectangle. What's that? 32 by 48. And then we're going to add it all up. Is everybody cool? Please notice, once again, is the math getting more difficult? No. Is the math getting longer? Yes. Because in grade 5, we would have given you one triangle and said, find me the area. I got it. Yeah. And then question 2 would have been find another triangle. Oh, I got it. Yeah. And if question 3 was find a rectangle. Oh, yeah, I got it. Okay. Well, what did we just do? Grade 5, question 1, 2, 3, but all in one question. Everybody good? All right. This blank is staying blank. We're coming back to work there later. Everybody cool?
Wait, 1 second.
It's not going to disappear. I'm just going to slide down a little. Did that go too far?
Yes. No.
Oh.
No, it didn't.
I don't know how to say I'm sorry in German.
Entschuldigung.
What?
Entschuldigung.
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 In French, it's je m'excuse.
Pardon-moi.
Or pardon-moi.
Excusez-moi.
Excusez-moi. There's lots.
Entschuldigung. That's the German.
I
should give you the title for the comedy. You're gonna love it. It's good.
Oh, your German movie that's a crazy horror film that you
It's
think
not
is,
a horror
you
film.
think's a comedy?
It's a comedy movie.
What are you doing? I'm counting matches.
Why is that funny?
Because German films are weird.
Not true.
I shouldn't,
Not
you know,
Weird to Americans, but not
you shouldn't generalize. I watch a lot of foreign films. Foreign films are weird.
Did you watch those?
Like Hollywood would be better.
I didn't say Hollywood's better. I'm just saying foreign films are strange. All right. So next, we got to draw and calculate the surface area of a cone. Well, what's a cone? What's it start as? Circle. And I'm going to put dots back there. What is the dotted part? The back of the circle that we don't see, yes? And then that circle repeats and we build that thing, yeah? All right. If I want the surface area, I have to decide what it's made of, right? Well, the bottom of it's pretty easy. What's the bottom of a circle? What's the bottom of a cone? Circle. Plus, what is the top? It's kind of a triangle, but
It's like a bouquet of flowers, kind of. Like when you wrap the stuff up.
I know for sure the first one there's a trailer.
that sounds naughty.
It's not though. It's
That, I think that is naughty.
They're making fun of like they have English class and they just can't do English, so that's how they write it.
There is
Like how
no
you would
German that
pronounce it.
cannot speak English.
Yes, those kids. Well, see, there's
Here's a triangle, agreed? Agreed? If I try to make it a cone,
well, that didn't work out.
what happens?
There's a point. This reminds
It doesn't
me
go
of
flat,
Rise
does it?
Yourself to Sleep.
Does it go flat?
No.
So it can't be a triangle, can it? Quite. Right? All right. So what it actually is a section of a circle. So it's actually a fraction of the circle. Okay? Now, you guys are smart kids. How do I find the area of a circle? Pi r squared. Now, how do you find the area of part of a circle? Well, let's build this like smart kids. If it was a full circle, it would be pi r squared, right? Okay. So I must need pi because there's a circle. I must need a radius because there's a circle. If it was a full circle, it would be radius squared, wouldn't it? Radius times radius. So I must need to multiply this radius by something. But I can't square it, or that would give me the whole circle, wouldn't it? What's the only other measurement left here?
The height.
Not quite the height.
The slant height.
The slant height. That's how you find the area of a cone, because it's this weird section of a circle. How did they work that out? With models. They figured out the formula with models. It's actually the same way they figured out pi in the first place, back in the Egyptian days, before they actually knew that it was circumference divided by diameter. They drew circles and they put squares in them and like cut the squares and counted and built pi that way. It is a lot of work. If you're even the tiniest bit interested in math, there's a 4-episode series on Netflix called The History of Maths, with an S because it's British. And in Britain, they don't call math, they call it maths with an S. Well, that's because Britain went around ruining most of the world to take it over, right? To straighten them out, right? Heaven forbid your civilization that's lasted 40,000 years, it's not as good as ours.
Have you seen the video on Facebook where it's like all countries playing Risk or so? It's
No.
really funny. I have to show you. It's really good.
All right. What was I saying? British maths. Oh, history of maths. It's really, really interesting until the 4th episode. The 4th episode gets a little crazy. But the first 3 episodes are really cool. Anyway, so we got this here now, yeah? Yeah. Now, what do we know? Do we know the radius?
No.
Read the question. Do we know the radius? Excellent. We know the radius. Do we know the slant height? No. What do we have? The height. Refer back to this asterisk. What does that say in red? If you need a slant height, you must use Pythagoras. To do Pythagoras, I need a triangle, don't I? I don't have a triangle yet, or do I? What's the radius? 15. What's the height? 22. Do you now have a slant height? How? Slant height squared equals what? 22 squared plus 15 squared, and I square root it. And that's going to give me a number. Now this is going to get weird, okay? Everybody find that number for me. And then we're going to do something that is going to bother a lot of you. It won't bother any of you from another country, but it's going to bother most of you.
Is it S2 or 5?
S, slant height squared. What's the answer? How big is our slant height? 26.62. Everyone okay with that? Yeah. Okay. So now, do I know my R?
Yeah.
15. Do I know my slant? 26.62. Can I now fill in my formula? Surface area equals pi times 15 squared plus pi times 15 times 26.62. Everybody cool? Okay. Now, stop for a moment. In previous years of math class, unless you were in my Honors 9 class, and you already know the story I'm about to tell you, in previous years of math class, what did you do with that symbol?
3.14.
You made it 3.14, right?
Yeah.
Which is a problem in math. In math class, we don't like that. And from now on, I really don't want to see it. In math class, you're going to leave it as pi. Unless you need a number. We'll talk about that in a minute. So if we're leaving that as pi, not doing anything with it, but I can do 15 squared, can I? What's that? 225. So this is 225 pi, right? Plus, not doing anything with pi, but can I do 15 times 26.62? What is that? 399.3 pi. Now, what do I do when I have 225 pi's and 399.3 pi's?
Just split them up and share it with your friends.
You add them. Right? So it is 624.3 pi. That's what I want to see. In a perfect world, I wouldn't even have done the square root over here. I would have left that as a square root. But we're not going to get to that till the third unit. Okay? Now, there's a problem with that. I have to paint this cone. I got to go to Home Depot to buy the paint. I'm going to go buy some Dusty Rose paint. Can I walk into Home Depot and say, hey man, I need 624.3 pi's worth of paint?
Probably not.
No, I need an actual number. So in math class, we're going to leave it as pi. In the real world, we would do, on our calculators, we would go 624.3 times the pi button, not 3.14. Everybody cool? Everybody cool? This is math class. This is real world. Because in the real world, you don't say, yeah, my circular lawn is 27 pi. Everybody good? Okay. I'll leave that up for a second. Is that long enough? Everybody caught up? Now, the answer here will be something around 1,872, so probably around 1,900. What is it really? 1,961? Not bad. All right. Number 4. Draw and calculate the surface area of a 20 centimeter soft drink container. See what I did there?
Yeah.
Excellent. It's going to be 33 centiliters.
What is that in millimeters?
330. All right. So, what shape is a pop can? Cylinder. So it's got a circle, then it's got a rectangle, then it's got a circle, right? So if I was going to build a formula for it, what do I have on the top and bottom? 2 circles plus the middle is what? A rectangle. 1 rectangle, yes? Well, the area of a circle I know is pi r squared. But how many of them are there? 2 plus. Now this guy, if it were a rectangle, it's length times width, yes? Everyone agree? So it should be LW. But there's a problem with that, isn't there? Because once I make this a cylinder, don't I lose one of the measurements?
No, because the height.
I keep the height, because that was the same, right? But don't I lose this? What does this become when I cylinder it?
Base.
It becomes the circumference, yes? Now, this is no problem. The W would go right here, right? We don't like calling that W, though, do we? Because it goes up and down. So what do we want to call it? H. Now, of course, there's a problem with that. Here's my cylinder, yes? Where's the height? Right there. Well, that's the width, right? Now what's the height? No, that's the diameter. What's the height? Now it's this. Is everybody with me? Just like base. Base can be the bottom. Base can be the starting point. Height can be that. That. Now what's the height? This way. Everybody with me? So we're going to call that the height, no problem. But now our problem becomes the length. And as Damaris says, the L is the circumference, isn't it? Well, how do we find a circumference? Yes, circumference equals pi d. But there's a problem with that. Because we're already using r over here, aren't we? So what is the relationship between r and d? 2 r's is a d, right? And since we're already using r, when the guys made up the formula for this, they made it 2 pi r's. Because they wanted to keep the r working with us. All right? So L is 2 pi r, and W is h. So what did they finally decide the formula was? 2 pi r squared plus 2 pi r h. And h is the problem one, right? Because h is simply the measurement between the circles. No matter how I orient the cylinder. Everybody with me? Mm-hmm. If I'm up in space, there's no up and down, is there? So height becomes a silly measurement. Picking up what I'm putting down? Mm-hmm. Right? How many of you grew up thinking, how do those people in Australia walk around? They're upside down all the time. I know I did. I was like, how do they, they're like this. Except they're not. Because we aren't on the top of the world, are we? We're used to seeing maps with Canada at the top. If I showed you a map of the world with Australia at the top and Antarctica at the top, you'd all go, ew, that's weird.
Wait, do they look at maps upside down?
No, they don't. But that's the problem. Maps and all that stuff, there is no up and down. There is no north and south in space. That is all made up for us on Earth so we can get our minds around it. Everybody with me? Okay, so now all we got to do is fill it in. 2 pi, what's my r? 5 squared plus 2 pi, what's my r? 5, and what's my h? 20. Now, back in the day, those pi's, you would have used a number there, right? What do we do now that we're in the 10th grade and going forward? We're going to leave it as pi. So, what's 5 squared? Times 2? 50 pi's. Yum. Plus, what's 5 times 20? Times 2? 200 pi's. Yummier. I had 50 pi's, and now I have 200 pi's, so how many pi's do I have? 250 pi. Now, math class answer, right? Now you're the guy in charge of the factory that makes these pop cans. You call up your metal supplier. Dude, I need 100,000 cans worth of metal. Well, how much is that? Each can's 250 pi. Does that help him or her? No. So in real life, we give a number. In math class, we leave it pi. Picking up what I'm putting down? Yeah, all right. Remember, even though pi, we don't give it numbers, all it is a number. Cool? Everybody good? All right. I think that's the end. Yes. You're going to turn your page over, and you are going to work on 29 through 31. But stop. There are some things you need to be made aware of. Everybody look at 29. Especially at the bottom. This is a reminder from last year. If the roof of that is not there, then that's real easy to find the surface area, yes? Once I add this part, I've added surface area. There's more than one way to do it. I am not going to talk about it because everybody has a different way to do it. You just need to remember that you do know how to do this. Okay? Some of you are going to remember the way you were taught in grade 9. As Luke was saying, -2 overlaps. If you were in my grade 9 class, I taught you a different way to do these that I think is less cumbersome. There's less work involved. When I go over it, I'll show you both ways that I do these things. But there's a couple of things you need to be aware of. One, it doesn't show up on your photocopying. This is a 90-degree triangle in 1B. That's 90 degrees. Okay? Turn the page over. Be very careful with F. A great many of you are going to make an assumption there that is wrong. So watch it. Everybody knows what these lines mean, yes? What do those two lines mean for those two distances? They're the same. And what does the one line mean? That they're the same, but they're different from this one. Okay? And I think that is all the tricks I have. When you get to the word problem, read it carefully. Okay? Go. I'll be walking around and offering assistance as is needed. In about 10 minutes, I would like to talk about just the first page. Okay? Everybody good? Yes, of course. All right. If you guys would be so kind as to have a look up front, there's a reason I'm doing this. This first one, it's a cube, right? How do you know it's a cube? All the sides are the same, right? Which means it's 6 squares, isn't it? And a square is, area of a square is the square of the side, right? So it's 6, oops, that's a horrible color. 6 times 5 squared, 150. Easy peasy lemon squeezy, yeah? Now, I am betting that every single person in the room did this next question the way I'm about to show you. I'm betting that. I am betting that you did this. 2 triangles plus 3 rectangles, right? The triangles are 6 by 8, yeah? So 2, 6 by 8 over 2, correct? Because a triangle is base times height divided by 2, right? And there's 2 of them. The 2's cancel, so your triangles were 48. Then, I bet you did one of the rectangles on the bottom, 8 by 7. So you went 8 by 7 and got 56. Right? Then I'm betting you went 6 by 7 to get the triangle on the back, or the rectangle on the back. 6 by 7 to get 42. Then you needed this rectangle here. And you knew that that was 7, but you didn't know this side until you did Pythagoras. When you went 6 squared plus 8 squared equals c squared, which is 100. So c equaled 10. So you knew that that was 10 So you did 7 times 10 and got 70. And then you added up all of that to get 216. Did everybody do something close to that? Everybody? Okay, now I want to show you something. This is a... Where did it go? Okay. I want to show you something. Earlier today, we talked about the formula for a triangle, yeah? I drew it on the board, and Luke said, oh, that's why it's the formula for a triangle. It's half a rectangle.
Okay. You're just going to continue it on by 7? Oh.
What did I just draw? So, if I go 6 by 8, 6 by 7, and 8 by 7 and multiply it by 2, I would get the whole thing, wouldn't I? Then I could do a prism divided by 2 plus this rectangle here, which would be 7 times the square root of 100. And I would get the same answer. Why am I showing you this? No, not because either. But because I want you to see that sometimes what isn't on the screen or isn't in the question can help you out. Okay? Let's come down to this one. That's just a regular rectangle prism, right? So I can go ahead and use the formula, can't I? So all I got to do the formula is know what W, H, and L are, yeah? Who names W, H, and L? You do. If you make that W and that H and that L, will it work?
Yeah.
What if you made it this H, this W, this L, and this W? Would it work? Why? Why would it work? Still the same numbers. Multiplying doesn't matter, does it?
Look, you made the little formula there.
So all I got to do is fill in the formula. 2 WH LW HL. Does it even matter what order I write these guys in? Why? Not quite. Multiplying is commutative. 5 times 2 is the same as 2 times 5. So all I do is I put in my numbers. WH, the way I've written it in red, is 4 and 3, right? WH, so that's 12. Plus LW, 12 and 4, 48. Plus HL, 3 and 12, 36. 2 times 96, 192. If I worked in red. If I worked in black, it would have been 2. WH would have been 36. Plus LW would have been 12. Plus HL, 48. Whoa! Exact same numbers. Don't get trapped in formulas. Learn what you're actually doing. Everybody cool? Now for this question, it was a little bit harder. I told you this whole thing was 12, and I told you that all these meant they were the same length, yes? But I never actually told you what length they were, did I? But I did. If this whole line is 12, and that 12 is divided into 3 equal pieces, then how big is each one?
3 millimeters each.
4.
Well, yeah, math.
Yeah, math. What with this being math class and all.
See, this is the easy math. That's
4,
that you get when you do all
4, 4. Right? Now, a great many of you probably did the grade 9 thing where you took prism 1, you added prism 2, and you subtracted 2 overlaps. How many people did that? Anything wrong with it? Not at all. I submit, though, that it is easier to do what I am about to do. Everything I'm coloring in green isn't on this one, is it? So isn't this D exactly the same almost as this one? So if I did the surface area of the bottom over here, and then I added how many of these? 2? 4, because there's one in the back, one on the other side. I would have the same answer, wouldn't I? Does everybody understand what I'm saying? So the bottom of this, I know, is 4, 4, and 12, right? So it's 2 times 4 times 4 is 16. Plus 4 times 12 is 48. Plus 4 times 12 again is 48. 96 and 16 is 112, right? Times 2. 224 covers the whole bottom, doesn't it? Including that, and that. Everybody with me? What is this green section? It's 4 by 4, isn't it? So the green is 4 by 4 to cover it. And how many of them are there? 4 of them. So that's 64. Plus 64. And I get 288. Significantly less math if I think about what I'm doing. Can you get through following the formula? Sure you can. But if you take a second and think about what you're doing, then it becomes easier to remember, oh, did I get that overlap? Did I not get that overlap? Whatever. Everybody with me? Yep. Is everybody cool? All right. How are people doing? Everybody got the next one? Should I go on? This one right here. This one right here is a little bit tricky, right? What are the tricks that you're going to need to do? Are you going to need that side? Yeah, you are. How are you going to find it? Pythagoras. Excellent. That's the only trick there. It's 10:45. We've got about 15 minutes left in class. Do we go on? Do I go on, or do I just shut up and let you guys work? All right, keep working. We can mark these tomorrow.